Here goes. Today we're going to work out the nth term of quadratic sequences. To start with, a bit of a recap. Can you show that the following sequence is quadratic? Can you find the next two terms? And, well, the extension is to find the nth term. If you've already figured out how to do that, I'm not expecting that, but it's there because we're going to be looking at that today. Pause the video, give this a go. I'm going to go through it now. So to show that it's quadratic, we need to show the second difference is constant. So if I work out the difference between terms, this is the first difference. It's going to be 8, 14, 20, 26. You can see it's going up, and it's actually going up by a constant amount of 6. So I'm not going to say any more. I could write a conclusion. The second difference is constant, so it's a quadratic sequence. Find the next two terms. Well, we know that it will continue. If it's a quadratic sequence, it will continue like this. So if I want to do 6 plus 26, that'll give me the first difference here. It's going to be 32, and then I'm going to add on 38. And if I add those on, if I add 32 onto 71, I'll get 103, and then add on 38, I'll get 141. So that is how we can work out the next two terms. But what about the nth term? That's the key thing for today. This guy here is really struggling with this question. Okay, here goes. To find the nth term, we actually return to the general formula. Un, that's the nth term, is an squared plus bn plus c. This is something that you might be given, or otherwise you will be expected to know. Okay, I would advise you learn this. This is a general quadratic, essentially. It's got n squared in it. It could have an n. It could have a constant term. B and C could be 0. A will be non-zero for a quadratic, but these are the numbers that you'll generally be given. We're just going to work in terms of the general formula because it's going to give the most ideas. Now, we've actually already looked at this a little bit. How can we find the first four terms? Well, we can substitute in n is 1, n is 2, 3, and 4 and see what happens. And if I substitute n is 1 in, I'm just going to get a plus b plus c, because 1 squared is 1 and b times 1 is just b. If I substitute n is 2 in, I'm going to get a times 2 squared, that's 4a. And b times 2 is 2b. That's what I'm going to get, 4a plus 2b plus c. This is a general quadratic sequence. I'm now writing the terms down for it. And then n is 3. It works in a similar kind of way. You'll see why this is so useful in a minute. 9a plus 3b plus a. And then finally, the fourth term, I will find this one. It's going to be 16a plus 4b plus c. Sorry, I made a little mistake on that one there. You might have spotted it. That should have been a c. Right. It looks like I'm just making it more complicated, doesn't it? But I'm not. Now let's find the first difference. It's going to be, what do I add to this to give this? It's going to be 3a plus b. Here, the difference is 5a plus b. Here, it's 7a plus b. And the second difference, this is actually something we did last lesson, is 2a. And it's always 2a. Now this actually becomes the focus for how we can work out the nth term because of this general algebra that we've done. We can use it alongside a numerical sequence to work out a, b, and c. And here's how. We can essentially compare this algebra with the sequence that we've formed. So I can see, for example, that if my second difference is always 2a, and in my sequence it is 6, I can actually set 2a equal to 6. And therefore, a must equal 3, and I found the first term of my sequence. But I'm not going to stop there. I'm now going to look at the first difference, 3a plus b, and compare that with 8. I can write down that 3a plus b is equal to 8, but now I know what A is. It's just 9A. Sorry, 3 times 3 is just 9, so it's 9 plus B equals 8. And so B is going to equal -1. And I found two of the coefficients, two of these numbers in the sequence. And finally, I've got A plus B plus C as the first term. I can just compare that with 3. A plus B plus C equals 3. Now I know what A is, it's 3. I know what B is, it's -1. So 3 minus 1 plus C equals 3. That's going to be 2 plus C equals 3. C is going to equal 1. And finally, I can write down that UN is going to equal 3n squared. I'm now substituting A, B, and C into here. 3n squared minus n plus 1. And I've worked out the nth term of the quadratic sequence here. Whew, good stuff. Here's a model example from scratch then. This is best practice, what I'd like to do each time. I don't want you to just like try and learn, learn that the second difference is always 2a and the first difference is always such and such. I want you to be able to derive these things because it's much more powerful, and once you maths is about understanding methods, I think, and being able to replicate them, not just like learning a bunch of facts and then applying them. But so our starting point is going to be, and we just need to, the more we practice this, the quicker we can get just the general formula: an squared plus bn plus c. Having said that, before we do that, we need to actually work out what the second difference is and so on. So we're not even told it's a quadratic sequence. So we find the first difference, 15, 25, 35, and this is going to be 45. So the second difference is 10. Okay, should have done that first. And now we take our general quadratic, you may or may not be given this, and we write it down. So when n is 1, we're going to get a plus b plus c. When n is 2, we're going to get 4a plus 2b plus c. The more you do this, the quicker you'll get. When n is 3, you get 9a plus 3b plus c. You can actually stop there. Don't write any more down. So next bit, I probably should have done that in black, to be fair, to make it the same as the numbers above. Next bit, find the first difference. 3a plus b and 5a plus b. And finally, the second difference is simply 2a. And now we are ready to go. So first step, compare 2a with 10. That's going to give us that a is equal to 5. And you need to do that one first. You don't want to, because it's the simplest one. Second step, compare 3a plus b with 15. And note, you could compare 5a plus b with 25. It's just go with the simplest one. Just makes more sense. So it's going to be, I'm going to write it down, 3a plus b equals 15. And now substitute a equals 5 in. 15 plus b equals 15. It actually turns out in this case that b is going to equal 0. And then finally, compare a plus b plus c with 8. So 5 plus 0 plus c equals 8, c equals 3. And finally, the nth term is going to be, we just substitute it back in the numbers we know into here. So 5n squared. There's no b term, so we can just ignore that, plus 3. And we've worked out the nth term of this quadratic sequence. What I'd like you to do now is try this one here. Find the nth term of this quadratic sequence. Try not to look at your notes. Don't just substitute in the values that you know. Like I said, I want you to learn the method. So go through the steps that I did. Okay, if you're unsure, okay, look at your notes a little bit, but give it your best shot at using the method I've given. Write it in full to work out the nth term of this quadratic sequence. No cheating, please. Just, when I say cheating, don't just substitute in that you know that a plus b plus c is 1 and so on. I want you to do it from scratch, okay? Go for it. Right, first thing, let's find the first difference. 5, 11, 17, 23. We are told it's a quadratic sequence, but we're just going to check. Then it's going to be 6, 6, and 6. So this is looking good. Next, write down our general quadratic sequence. A n squared plus bn plus c. And substitute in. N is 1, n is 2, n is 3. We don't need to worry about the rest of them. We're going to get a plus b plus c, 4a plus 2b plus c, and 9a plus 3b plus c. First difference, 3a plus b, 5a plus b. Second difference, 2a. Now we're in business. 2a equals 6. So a is equal to 3. 3a plus b equals 5. But we know that a is 3. So 9 plus b equals 5. B equals minus 4. And then finally, a plus b plus c equals 1. But we know what a is, and we know what b is. So 3 minus 4 is minus 1. Add the 1 to both sides so we can see that c is equal to 2. And we have the nth term as 3n squared minus 4n plus 2. There we have it. Over to you now. Here are loads of questions. Can you work out the nth term of these quadratic sequences? Each time I just want you to go through the whole process because it will really embed the ideas. Give it your best shot. Go for it. I'll show the answers in a minute. So I hope there's no mistakes in the answers. Here goes. These are the nth terms of A to P. Got some really interesting sequences going on. Okay, some that start the same and then they differ. You can see so E and G start the same, but we've got very different sequences overall. If you're happy with that, then here are a couple of extensions. Find the nth term of this sequence and have a go at this question here. I'm going to go through these last two in some detail because they are the challenge questions. Alright, here goes. So you might think, it's just another one. But let's find out what happens. So if we find the first difference, it's going to be 5, 15, 31, 53. Second difference, 10. Oh no, it's not going up by a constant amount. It's actually 16 and then 20, 22. Actually turns out in this case that the third difference is constant. What does that mean? Well, if the first difference was constant, it was a linear sequence. The second difference, quadratic, this is actually a cubic sequence. So it's a good extension because it requires you to think about, but you can use the same method to construct, to try and find the nth term of an cubed plus bn squared plus cn plus d. That's what we're going to try and do now. So same process, and this is why it's such a powerful method. Right, we're just going to substitute in n as 1, a plus b plus c plus d. N is 2, 8a plus 4b plus 2c plus d. N is 3. I'm just realizing here I'm not writing this small enough. We're going to get, for n is 3, 27a plus 9b plus 3c plus d. And finally, for n is 4, 64a plus 16b Well done if you're sticking with this. I should actually show the answers, sorry, because you might just want to know if your answer is correct. Here we go. Plus 4c plus d. Okay, not very nice, is it? Right, now it's the first difference. It's going to be 7a plus 3b plus c. Then 19a plus 5b plus c. Then 37a plus 7b plus c. Second difference, 12a plus 2b and 18a plus 2b. Third difference, 6a. We've done the hard work now. I can compare 6a and 6. So a is 1. 12a plus 2b. Of course, I've not proven for sure that the third difference is constant, but it is, okay? I'm not going to go into that. That equals 10. So 2b is going to be minus 2, b is going to be minus 1. Done that quickly, but yeah. 7a plus 3b plus c is 5. So I'm just going to substitute straight in because they're quite nice numbers. 7 minus 3 plus c equals 5. That's 4 plus c equals 5, so c is going to equal 1. And finally, a plus b plus c plus d is 0. So I've got 1 minus 1 plus 1 plus d equals 0. And d is going to equal minus 1. And when I substitute those numbers in, I will get this one here. Okay, this is, I should have said, like, this is beyond GCSE. It is the same method, and I think if you can understand this, then you're sorted. You could deal with quartic sequences and so on. Really effective ways of finding the nth term. And if you can do this, you should be really confident with your quadratic sequences. Let's take a look at this last one. So we're given this first 10 sides of a spiral pattern. It also gives the lengths in centimeters of the first 5 sides. Work out in it. Okay, so it's drawn 10, but it's given us the distances of the first 5. All right, how is this different? Let's find out. Well, I've got my terms of the sequence. 1.5, 3. Looks like it's doubling, but then no, it's not doubled here. Okay, I guess we're dealing with a quadratic sequence where we've got some decimals in there. Let's find out by finding the first difference. Yep, that's going up by a constant amount, and the second difference is going to be 1. So I might, just in this particular one, not go through all the steps now. I know that 2a is going to equal 1, so a is going to equal 0.5 or a half. I then know that it's 3a. Let's jump back to all the way up here. It's 3a plus b is equal to the first difference. So it's going to be 1.5 plus b equals 1.5, and b is actually going to equal 0. And then finally, a plus b plus c is going to equal 1.5. So it's going to be 0.5 plus b, which is 0, plus c is equal to 1.5. And so c is going to equal 1. And I think it's going to be 0.5 n squared plus 1. I thought it might be more complicated than that, but if we just substitute in maybe n is 4, then I'm going to get n times n is going to be 16. Divide that by 2, 8 plus 1, that is going to give me 9. So I can be quite confident it worked for that one, and I've done it for the other one. So okay, just a bit of an application question, and the fact we get a decimal in the answer. Amazing topic. I hope you agree. I hope you're coping all right with it. Keep practicing. Well done on all your efforts. Just a quick bonus video to finish with. So here I've got a linear sequence. It's actually going up by 3 every time. And previously we've looked at how to work out the nth term of this sequence. So it would be 3n, because it is sort of the 3 times table. And then we can minus 3 from the first term to give us 4. And that's the 0th term. So it's when n is 0, and what are we left with? Well, it's going to be 4, so it's going to be 3n plus 4. I'm not going to get into any more detail on where that came from, but like if you forget that method, then here's another way you can do it. If you recognize that it's a linear sequence, then you can write down the nth term as an plus b. And then you could write down the first few terms. So the first term is going to be a plus b, and the second term is going to be 2a plus b. And then we see that the first difference is going to be a. So that immediately gives you your 3. So we can see we can compare the a with the 3, get a equals 3. And then what we can do is we can compare the 7 with the a plus b. So substitute 3 in, and we're going to see that b is equal to 4. So it's another really nice way of doing it. And if you sort of forget or struggle with this method a bit more, but you're confident with the using the nth term, and this is a good shout.